Which one should I go with? Is the simple question that you must understand before you can recommend one to your customers. SQL virtual machine, like the term says, this is best for any migration projects or any customer who says I need the same level of control like I had in on-premise environment. This is where we are talking about application level or OS level accessibility, right? A control. So if you need the same level of accessibility, the same level of management, so you go with this option, which is SQL on Azure Virtual Machines. Now, if somebody says I need less management overhead, but I'm looking for more flexibility, that's where you have your SQL databases coming into play. Now, keep in mind, in SQL database offering, you don't get all those features, okay? I would recommend SQL databases to somebody who says I want to build modern applications, potentially multi-tenanted, with uptime and predictable performance. That's for them. So when do I go for managed instance? Managed instance is where you say, hey, I need less management overhead, but certain features to be available to me. Features like service broker, features like SQL Server Agent, features like CLR. So if you need these things, you go with the option number 2, SQL Managed Instance. What you see on screen is also a table which quickly highlights the differences between SQL Managed Instances and SQL Server on Azure Virtual Machine. Like I said earlier, Azure SQL Database offers the best flexibility, which means least management overhead. But remember, some SQL features are not available. So that's where the managed instance come into play. Managed instance says, hey, I'm going to give you extra feature, controls on extra feature, which is instance scope, which is where I've talked about CLR, Common Language Runtime, SQL Server Agent, Service Broker, Distributed Transactions, right? Other machine learning services are also available to you with Azure SQL Managed Instances. The third option, SQL Server and Azure VM, it clearly says, hey, if you want to migrate an application to the cloud as fast as possible, but want to maintain the same control on the operating system and the SQL Server functionality, which is application, you go with the third option. Check out the sizes. If you see a SQL Server offers the size of 100 terabyte, whereas your managed instance gives you only 16 terabyte, whereas a SQL Server on a virtual machine can go up to 256 terabyte. So it also depends on the size of your database, which service to choose from. So let me pause here for 20 seconds and let me ask this question. Is there anyone in this training who is from database background or application development background? Because most of the developers have some or more knowledge on databases as well. So my question is, anybody who is a developer or who is a database administrator, just raise your hand for me. It's like most of us are from operations or infra background. Because if you have a database guy, it becomes really easy for us to understand his point of view as well in real time. Okay, I see no hand rises, so which means most of us are from operations and IT infrastructure background. Okay. So these are the 3 database offerings which we have. Habib, which one should I choose? So my first question would be, what's your use case? Hey, if my use case is to migrate it to the cloud, I would say go with Azure SQL databases. Because price-wise, database size-wise, and then the feature-wise, this one offers the best flexibility. If somebody says, I want to deploy a solution which is cloud-native, and I want to have instance scope feature, then I would go with managed instance. Azure SQL is also good for lift and shift, which means for migrating your applications, provided if you need that control. If you're not looking forward to that control, no need to go with it. Does this make sense, everybody? Just give me a thumbs up if you're following me. Thanks, Rishi. Thank you, others. So now the question is, how do I buy? Okay, so whenever we're talking about buying the Azure SQL database solution from Microsoft, you have to understand the pricing model. So the pricing model can be based on DTU, which is known as database transaction units, which is what I've written here. So we have 3 offerings, basic, standard, and premium. or it can depend on the virtual cores, which means depending upon the logical CPUs of your database, you can buy it, or it can be serverless. So these are the three options that you would generally see. So DTU generally combines your CPU, memory, and IOPS together. So that's what it does. That's what I've written. It's a package, which means tomorrow, if I need more resources for my databases, I have to add resources from all the friends, CPU, memory, and storage as well. This solution is suitable for clients who look for a predefined resource configuration which balances CPU, memory, and storage together. So default is always DTU based licensing. Okay. Then we have virtual core for any existing on-premise SQL server which you are migrating in the cloud, because most of the database licensing is core-based, right? And if you want to follow the same procedure even in the cloud, you can go with your vCore purchase model. So vCore represents your logical CPUs of your virtual machine. Basically, the physical characteristics of the hardware is what we rely on to go with it. In vCore purchasing model, your cost actually depends on the configuration of the hardware, the compute resources, the database storage size, and then the backup that you're considering. All these factors would come into play when you want to go with vCore. The term vCore generally represents virtual core, which is virtual CPU of your machine where your database instance is going to run. Again, general purpose, business critical, and hyperscale are few of the tiers which are available to you in vCore, which we're going to discuss. And the vCore you also can go with serverless compute tier. So in vCore, you have two options. Do you want to go with compute tier, where the full-blown virtual machines are deployed for you, or do you want to go with serverless, which means you pay only for the resources that you have deployed when that particular instance was active. So both these options are available to you. Now let's talk about the service tiers which are available to you when you go with the licensing model of vCore. So if you see here, three service tiers is what we have: general purpose, business critical, and hyperscale. General purpose is what I call it as budget friendly. We change color. General purpose is budget friendly tier, designed for most workloads. It covers your performance and availability requirements. Business tier is designed for performance sensitive workloads. Where we are talking about single digit millisecond latency factors. Hyperscale is the tier which is designed for business workloads, providing high scalability, storage, and read scale up. So faster scaling is the option which this guy has to offer. Now the first question is, how does it work in general purpose? So if you look at the general purpose diagram here, it clearly shows you the concept of an always on availability group. So that was business critical, my bad. So in general purpose, it clearly highlights what it's doing. So let me just bring you access to one of the KB articles where the explanation becomes a little bit easy for us to digest. So I will just go here, I will type general purpose. Then we have, what was the other one? Business critical. And hyperscale. See here, vCore purchasing model, service tier. Scroll down, three tiers is what we have discussed. General purpose, business critical, hyperscale. The first point which we said was most of the general workloads. Any business critical application with highest I/O performance, widest variety of workloads, but highly concentrating on the scaling factors. compute size, storage type, storage size IOPS. If you scroll down, this is the point that I wanted to bring in. So it begins with the application connecting to the server name, which will then connect to one of the gateway components that will point the application to the server, the database server to connect to. So there should be another diagram which should show you. Hold on, this doesn't have the diagram, but it has the same explanation. Let me share this first with you all. Then I will search for the other diagram, then we go forward. Let me click images also. I'm looking for a particular image. Okay, this one. This is general purpose. Yep. So this one, I just wanted to highlight this picture because this picture defines how your general purpose deployment service tier really works. So let me copy this diagram over to the whiteboard so that I can make, okay, we already have it. This is the diagram. So to see here, diagram which I posted in the chat box. Like that. Yeah. Click on that link, you will see this diagram. So if you see here, I will divide this process into 4 steps. Number 1, when your application wants to get access to the data, which means your front end is trying to reach out to the back end. So what's really happening? Step 1, if you see, let me just number it. Step 1, your application connects to the server name, which will then connect to a gateway component. That's what I've highlighted here, the box. The gateway component. And then we are talking about that gateway component pointing your application to one of the servers. So this is where you're contacting the gateway component, and then you're contacting the gateway component, then you're getting the application server. Then step number 2, you're reaching out to the database server. So the application is trying to connect to the database server. Now, this is where the term primary replica comes into picture. So it uses locally attached SSD for temp database file, as you can see on the screen. And then the data and log files are stored in Azure Premium Storage, which is LRS, locally redundant storage. That's exactly what we have written here. Data and log is premium storage with LRS. And then the other point to remember here is the backup files are stored in Azure Standard Storage, which is RAGRS. So at any given point of time, if the primary replica fails, what will happen? Your application server will contact the gateway component. The gateway component will then mount you to the new primary replica. So at this particular stage, I want you to remember keywords called FCI. So what really happens during this failover period is it will be doing something called a failover cluster instance, which means a service fabric will locate a node with spare capacity. So FCI, locate nodes with spare capacity. That's point number 4. Now, once it has located the instance with spare capacity, the database files will then be attached. So step number 4 is this. The database files will then be attached. A recovery will run. So step number 4 is where we say recovery will run. And then gateways will be updated to point the application to the new node. So these are the steps which happens behind the screen when we talk about general purpose. Now the point here to remember is in general purpose, there is no always on availability group, which means there is no multiple replicas which are running side by side. There is no synchronous replication for your database. That's why the first point which we have highlighted here is, hey, it's a budget-friendly solution, a service tier that can be selected for your database. So point 1, when application wants to access your database, it is reaching out to the gateway component. Point 2, your gateway gives you the details about database server. The application contacts the database server, which is your primary replica. To your primary replica, we have talked about where does your database and log files reside and where does your backup files reside. If that primary replica goes down, what is the gateway component doing at the behind the screen? It does something called FCR, which is failover cluster instance, right? And then it will locate a spare capacity. If not found, it will spin up a new SQL Server instance. So it will find up a node with a spare capacity, and then it will spin up a new SQL Server instance. Then the database files are attached, recovery will run. That's your step number 4. And finally, step number 5, let me use a red color. Your application now reaches out to the new replica. Reaching out to new replica. Now the term replica generally fools us because we understand that the moment you say replica is a duplicate copy, so the understanding is you'll have a running duplicate copy somewhere in the environment. It doesn't. So that's what we are trying to highlight. So no virtual network or listener updates are required for this particular service tier. Give me a thumbs up if you're following me so far. That's for your general purpose. On the other side, business critical is where you have always on availability group. But before we talk about always on availability group, everybody clear with general purpose? So we said, what are the different database storage offerings? Then we have talked about the differences of the 3. Then we have talked about how you can purchase, which is where DTU versus vCore comes into the picture. Then within vCore, we are talking about service tiers. And within service tier, the first tier is general purpose. Everybody good so far? Give me a thumbs up, people. Thank you. Let's get going. Srishi? Business critical, on the other hand, offers highest performance and availability of all Azure SQL service tiers. So anywhere you require performance for your sensitivity workloads, you go with business critical. Now in business critical, the first point to acknowledge is you have something called always on availability group. What do you mean by this? Hey, the same step. If application wants to access your database, step 1, it is reaching out to the gateway component. Step 2, the gateway component will give you the details about your database server. You're reaching out to the database server to fetch that information. Now, this space here, you have multiple replicas. So if you see here, you have primary and secondary replicas running side by side. Any data that comes to the primary replica will get replicated to secondary replica, which means all of them will have the same copy. So if at any given point of time, if an application writes data by using a read-write session and immediately reads it by using read-only session, the latest updates might not immediately visible on the replica. The latency is caused by asynchronous transaction log or a redo operation, remember that. But however, most of the time, you will see the data being replicated to the secondary replicas right away, okay? So what we are trying to highlight here is if any type of failure occurs and then it determines that your primary replica is down, failing over to secondary replica is fast. Here's step number 3. Let me highlight it here. Step number 3, if something goes wrong, failover is fast. failover is fast because the replica already exists, which is not the case in general purpose. In general purpose, what are we doing? Locate a node where spare capacity is available, then spin up a SQL instance, then attach the files. So you're doing a lot of jobs behind the screen, which causes the latency. In a failover, you don't need a listener, even here when we are talking about your business critical applications. The gateway will redirect. So step number 4, once your failover is successful, step number 4 is from your application redirecting to the new master replica, which will then process the request. So this is what we have. Hyperscale service tier is available for Azure SQL database offering only. Only available for Azure SQL DB. What do you mean by Azure SQL DB? Remember, we have 3 options: managed instance, SQL DB, and your third option, which was SQL on virtual machines. So this option is available only if you're going with the first one, which is Azure SQL DB. So this comes into play whenever we talk about tiered layers of caches and paid service. So the point to remember here is we are offering you a tiered layer of caches and paid service. So this gives me the opportunity to expand the databases quickly. So this is the main point. And then it also uses the concept of snapshots. Instantaneous backups, regardless of the size. So these are the 3 different tiers which are available to you when you are going with virtual core offering of a database in Microsoft Azure. I'm just going to pause here for 20 seconds. Check out the points on screen and let me know if there is any question. I see a question in the chat box. Is there a load balancer between application and SQL Server? The application gateway component itself will take care of it. There isn't any specific load balancer configured.
So how did the application know that which specific, like if the primary replica is down, is there a different endpoint configuration, something that application needs to be aware? Everything is automatic?
It's automatic. That's where the gateway component comes into play. So your application doesn't reach out to the instance of your database, right? Because it being a platform as a service offering, you do not have control where your database is running. You will just select the region, but on which instance, which machine, which rack, which server, you don't have control over that. It's the gateway component which knows about it. And it's the same component which will establish the communication again.
All right. Okay. So basically, it's fetching the details from the number 1 and then taking it up.
Exactly.
Okay.
It is a gateway component which is helping you out.
Okay. Perfect. Makes sense. Thank you.
So those were the tiers, service tiers offering. Now the question is, writing data is one part of it, but securing the data is very, very important. So whenever we talk about data security, you have to consider 3 aspects of it. First, discover the data, then classify the data, then protect your data. So what do you mean by classification? So this is where you need to understand, hey, can I present this data to the internet, which is public? No, it is only for internal employees, okay, confidential. Or is it restricted, which means even within internal employees, it's not available for everybody. So this is where you have your classification coming into picture. Once you have classified the data, then you will bring different mechanisms to protect your data. For example, when we talked about storage accounts, we said we can rely on Azure Virtual Networks Firewall. We rely on private endpoints. We rely on service endpoints, right? We rely on SAS, shared signature, shared access signatures. So all these settings were helping us for storage accounts. Similarly, what services we have? For data at rest, we have something called TDE, transparent data encryption, which allows you to encrypt any data that is residing within the database by default. So for transparent data encryption, we rely on encryption at file level, right? TDE also solves the problem of data at rest encryption, and then it encrypts database both on hard drive and consequently on your backup media as well. So more information about your TDE is what I've given you here down, which gives you more details. Similarly, we protect data in transit, which is where we are relying on SSL or TLS certificates, which allows you to encrypt the communication between a client and a server. And then when we talk about data in process, we're talking about data masking. DDM is what developers will call it, dynamic data masking. It is a kind of emerging technology that aims at real-time data masking of production data. What do you mean by masking production data? Which means limiting sensitive data exposure by masking it to the respective privileged versus non-privileged users. For example, I have a friend who works in UOB Bank here in Singapore, right? In earlier days, if you're a database administrator whose job is to just manage it, when I say manage it, make sure it's updated, make sure it's fast, and then the backups are taken on time, everything. So your job is just to manage it, right? But because you are given certain privileges, you were able to access the customer records as well. That was possible. So we don't want that. So what we wanted was, we wanted to bring in the differentiation point between who owns the database versus who manages the database, which means between a database owner versus a database administrator. So this is where we have talked about always on encryption. So if you scroll more, what is always on encrypted? Always encrypted is a data encryption technology that protects sensitive data at rest on the server and as well as during movement between the client and the server. So always encrypted ensures that sensitive data never appears as a plain text inside a database system. So after you configure data encryption, only client application or application server that have access to the keys can open the data. If I'm an administrator, I won't have access to the keys, which means I can't generally open those records. That's what always on encrypted does. How do I get started with always on encrypted? First step, you will create and populate the DB schema. Second step, you will encrypt the columns. Third step, you will query the encrypted columns to fetch the information required. So if you see here, this provides a separation between the person who owns the data versus who can view it, and there's who manages the data, which means I want the application owner or the database owner to view the data, but not the person who's just managing the database. That's always encrypted. And this is where we will pause our lecture. The last part which I'm highlighting here is how to scale your database. Depending upon the database type that you have selected earlier, whether it is managed instance, whether it is SQL Server on a virtual machine, or whether it is Azure SQL database, your options will vary. For example, if your requirement is to have and manage your Azure SQL database that have varying and unpredictable resource requirements, we say deploy it as Elastic Pool. What do you mean? When you go to Home, search for Azure SQL, when you select the service SQL Server database, from the drop-down you have the option for Elastic Pool, which means group of multiple instances running together to work for you, to process your requests. If you have the different sections of the database reading and residing in different parts of the world, and you want to perform better, then you go with something called sharding. So horizontal scaling by sharding is what we would recommend. I mean, if there are any dependencies such as commercial BI or data integration tools, then you go with Elastic Database Pools. So these are the different configurable options which are available to you in regard to scalability. Any questions here, guys? Again, will I use this? It completely depends if you're going to be a database, a person who's going to deal with our database people, right? So just remember that. So let's go back, hit the deck. That's it. That was what I wanted to bring up on the whiteboard. give me like 15 more minutes and then we'll be done with the deck. Then we can take a small break, come back, start with your case studies. Today we are going to do 2 case studies, one for the relational data storage solution and one for the non-relational data storage solution. Because we have less than 15 people in the room, we'll go with the same room discussions, though I've created the Teams channel for both the groups. Because it's less than 15 people, we will just stick to one group. It's about 28 slides. Let's quickly complete this. Design a data storage, we already know this. We have discussed what we mean by structured, unstructured, and semi-structured. Okay, it's not writing. Hold on. Let me just change pointer option. So structured versus unstructured versus semi-structured. So this is where we have talked about RDF. Remaining points are same. Azure SQL databases, we saw 3 options. SQL virtual machines, which is where we emphasized on the control part. Managed instance, which is where we have talked about scope, instance features. Inclusive, which is where we have talked about an example like CLR, SQL Server Agent. Databases for any modern cloud applications. Best fit for lift and shift. It doesn't mean that I can't use virtual machines for lift and shift. I can't use managed instance for lift and shift. You can. It's just that what is your real requirement depending upon that, because the pricing also varies. The size also varies. This one can go up to 100 terabyte, this one can only go up to 16, and this one can go up to 256 terabyte. We also talked about the pool, like Elastic or your instance pool. Elastic or instance pool come into play when you want to have resource sharing more the database and you want to make them work together. So it's both services are simplified, performance management for multiple databases, and offer to you as a pass. Scalability, like we said earlier, depending upon the type of database that you use, your scalability options would vary. So if you want to scale multiple Azure SQL databases that have variable, unpredictable resource requirements, go with Elastic Pool. If you have database which is spread across multiple different countries, then you go with sharding. If you have dependencies on integration tools like Power BI, and then if you want to view results for use in Excel, Power BI, Tableau, or Cognos, go with Elastic Pool. Consider cost together with your scaling technology for optimal solution. Like I said, the reason why we are saying cost is because you're going to occupy more space depending upon the service that you choose. We have talked about the purchasing models, DTU, database transactional units. It's a package, combined measure of compute, storage, and I/O. So I can't increase only storage, I can't increase only CPU. I have to do it as a one whole thing. vCore offers flexibility, which means if I want to scale compute, storage, and I/O resources, I can scale them independently. This is the first point. Under vCore, we also have full compute tier or serverless. So if your environment is intermittent and unpredictable usage, and you want automatically scale compute based on workload requirements, go with serverless. Then we have talked about under vCore, we have multiple tiers: standard, which is also known as general purpose, business critical, and hyperscale. So these are the steps which we've already discussed. These are used for most of the common workloads. Budget oriented and users nodes with separate state capacity. This is the reason why it is a little bit slow compared to your business critical. In business critical, what is the plus point? Always on availability group, which means, hey, at any given point of time, I have multiple machines running, primaries and secondaries. So if primary replica goes down, the failover is instantaneous. Then we are talking about hyperscale, which is designed for any large OLTP databases as long as they are equal to or larger than 100 terabyte. Can help you with auto-scale storage and scale computes, restores in minutes, scale up or down in real time to accommodate workload changes. Database failover strategy. If you want your database to be protected, you must consider a DR strategy, which means primary site, secondary site. At any given point of time within primary site, you have your always on availability group. If the whole site goes down, then you have your secondary site comes into picture. So this is match the following, I'm skipping that. Then we have talked about the security strategies. With respect to network, configure your VNets accordingly, configure your network security groups, firewall rules, private links. We do this. Identity and access, we're talking about integrating your databases with Azure Active Directory using RBAC to define permissions, who can do what, roles and permissions, and row level security can be configured. Data protection is where we are talking about encryption in use, which is always encrypted, whether it is data at rest or data in transit. We have data at rest, which is TDE. We have data in transcript, which is TLS, which is also known as in-flight mode. And then we can either use Microsoft platform managed keys or user managed keys. Dynamic data masking is a feature which is supported here in this pillar. And the security management, we can bring all this advanced threat detection, SQL auditing, integration with analytics and event hubs, vulnerability assessments, data discovery and classification, Microsoft Defender for cloud. All these options would help you manage security for your databases. To authenticate to Azure SQL database, once it is integrated with Azure Active Directory, you can use an Azure Active Directory account, you can use a SQL Server database account, or you can use an account from Azure Active Directory which has Azure AD administrator role, Azure AD database administrator role. We're also introducing you to something called SQL Edge, which is basically coming into play whenever we're talking about big data. So this one here offers a relational database engine, which is meant for IoT devices. What do you mean by IoT devices? So any IoT environment will generate humongous amount of data. And if I want a solution to get connected and then help you process the data, that's where Azure SQL Edge comes into play. Capture continuous data streams, integrate the data in comprehensive organization data solution, overcome connectivity limitations, overcome slow or intermittent broadband issues. All these can be fixed with Azure SQL Edge. I gave you a quick introduction to tables versus Azure Cosmo database. So Cosmo database, many benefits: automatic instance scalability, enterprise-grade security, just-in-time, build fast with no ATL, broad API compatibility, and pricing is always based on usage and storage. So all these things is what we have when we talk about Azure Cosmo DB. This table here gives you a comparison. I already gave you this table. So if you remember the differences in the behavior, your Cosmo database will charge you only for the data that you have consumed. Query results from Azure Cosmo DB are not stored in order for a particular partition key. Row keys in Azure Cosmo DB are limited to 255 bytes. Cross-region resource sharing is supported by Azure Cosmo DB. Table names are case sensitive in Azure Cosmo database. So these are not case sensitive. Remember that. This picture talks about the compatibility APIs which are available with the Cosmo database. So what do you mean by this? So what we're trying to highlight here is, if you are a guy who's dealing with dashboards, so where you want to manipulate your graphical data and visualize it using Data Explorer, then you can go with something called an API Gremlin, right? So this one comes into picture. And if you are talking about doing data modeling for health tracker data, which involves telemetry and sensory information, so this is where your Cassandra API comes into picture. Anything related to telemetry and then health tracker information. So Cassandra DB comes into picture. Similarly, when we are talking about your Mongo database, we're talking about purchase orders. For an e-commerce website, you can think of purchase orders that can be stored here. So each API has its own benefits. For example, When we talk about core SQL API here, this one is recommended, such as storing cache data. The other one that I could think of is session management. So all these different APIs are supported by Cosmo database. So it offers multiple database APIs to provide native interface for multiple NoSQL databases. So which means if you are a developer and if you want your data to be modeled and queried with the language that you are comfortable with, we support all of this. And this is where we pause our lecture and then take a small break. So that was all about databases, guys. So give me a thumbs up if you are following me so far. If you have any questions. All good so far, people? Just give me a thumbs up if you're following me. It's Vijay. Jacqueline, thank you, others. So the next point here is the time. Okay, time right now is 2:03. Maybe a small break, a 15 minutes break. Okay. Freshen up, come back. Today we'll be doing two more. Non-relational, relational. There is no lab for data integration, which we haven't discussed. We'll push the data integration for tomorrow. See here, there is no lab for data integration. So today, case study number 3 and case study number 4. This one here is non-relational storage case study. This one here is so these are the two case studies for today. You already know what to do. You already have the Word document. Yesterday we did discuss how to get started. Take a small break. I'm just going to bring up the timer. Take a small break. Come back after the break. Because it is less than 15 people, we are going to sit in the same room. Unlike yesterday, I won't jump in with the solutions today. Let me see if anybody wants to step up and then help me out with an update. If not, you can individually work on it and then you can privately message me your solutions. Okay, I'd leave it up to you. So time right now is 2:05. Let's take a 15 minutes break. And once you're back, what we'll do is, we will just stop sharing the screen, start with the learning environment, in the case study environment. It's up to you. If you want to participate, you go for it. Because yesterday nobody stepped up, I had to do it. Or you work it on individually. I'll give you some time for both the case studies and then we will run through that. So for now, enjoy your tea break and be back in time, guys. Thank you.